Hello, everyone, and welcome to today's webinar, Protect Against Machinery Breakdown with Risk Engineering. My name is Jared Shelley, and I'm Demand Generation and Content Marketing Manager for Tufsude Global Risk Consultants. With today's hard insurance market and fractured supply chain, companies need to do everything possible to get an edge. Limited insurance capacity and long lead times make it even more important to reduce a critical risk, equipment breakdown. Breakdowns in boiler and machinery equipment can cripple any company's productivity, lead to business interruption, and have a major impact on financial performance. In fact, major insurance providers estimate that losses connected with boiler machinery failures are twice as high as those incurred through fire related losses. Condition, age, and maintenance are all factors in keeping equipment like boilers, pressure vessels, or mechanical assets running at full capacity. I'm joined today by two experts. Paul Sinowitz is Global Boiler Machinery Manager here at Tufsude Global Risk Consultants. Paul is a risk engineer and boiler expert with 45 years of experience and 15 with Tufsude Global Risk Consultants, specializing in loss prevention inspections for global clients. His expertise includes power generation, steel, paper, food, automotive, and much more. His prior experience includes risk engineering at Zurich North America, Hartford Steam Boiler, the U.S. Navy, and other predictive maintenance consulting. Bryce Hart is Senior Consultant of Boiler and Machinery Engineering at Tufsude Global Risk Consultants. He is an expert in boiler machinery breakdown with more than 30 years of experience in the field. He has worked with the U.S. Navy, Hartford Steam Boiler, Zurich North America, FM Global, and others. In today's webinar, we will explain the keys to protecting against machinery breakdown, why today's supply chain issues make risk engineering even more critical, independent risk engineering versus engineering bundled to underwriting, specific examples of boiler machinery risk engineering success. We will conduct today's webinar interview style with me serving as the moderator after questions of our panelists. If you have a question, please put it in the Q&A box on your screen, and we will answer them at the end of the presentation. So thanks, guys, for doing this, and let's go to our first question. So what are the considerations when discussing machinery breakdown? Who wants to take that one?
I'll start off first, Jared. Thanks. When it comes to boiler machinery breakdown, risk and exposures, there's four loss prevention considerations that we have to take into consideration. First one's property damage, business interruption, contamination, and consequential damages. Bryce, you want to fill us in on some property damage?
Certainly. Thanks, Paul. So what we're talking about here is physical damage to equipment. For most people, when asked about property damage, they think about their home or some other personal possession like a car or a boat. In the boiler and machinery world, property damage applies to the equipment on the property, basically what is inside the building envelope. This could be production process related equipment, might be equipment providing a utility service that supports production, or equipment providing control and protective functions. Some examples of property damage include rotating equipment. There might be a roll failure in a paper machine, maybe a single dryer can, maybe the entire Yankee dryer. Or it could be a motor failure in a dust collector blower or in a hydraulic power plant. Electrical equipment, it might be damage to the electrical distribution network, or a computer server could fail, resulting in a loss of control programming. And mechanical could be a collapse of a cooling tower that would disable your cooling system, or a boiler accident resulting in a loss of steam or hot water for your process. Paul, you want to take the next one?
Sure. With business interruption, most people are familiar with property perils such as fire, explosion, windstorms. These type of events can devastate a business just with physical damage, but almost always will end up with some type of business interruption. But when it comes to boiler machinery assets, things as Bryce said, mechanical breakdown, such things as a centrifugal explosion, a centrifuge explosion, you could have a cracked rotor or a shaft, a turbine overspeed failure, gearbox fails. With electrical equipment, you can have things like arcing and switchgear, transformers can explode, or motor insulation can fail. Steam boilers, you have things like cracked welds, low water condition where you damage the tubes where you melt them, collapse the furnace, or the most catastrophic event you can have with the steam boiler is a boiler explosion, which you will have significant amount of building damage, and anything around that boiler will be damaged, or hopefully there won't be any people involved, so we won't have to worry about personal injury. But these assets are vital to the production flow and the continuation of your business. So failures of assets like this will almost always end up in production and process interruptions. So our questions are, how well is your business prepared to sustain one of these events? Are there installed spares available? And what kind of contingency plans do you have? So as part of the risk engineering evaluation, GRC consultants are going to measure the business interruption risks and the exposures of the assets. So when our clients have this information, they can always make a more intelligent decision on how much appetite for risk they have. And the other thing we do is we can make recommendations to help our clients minimize those risks and exposures. Bryce, you want to talk about contamination?
Sure can. Thanks, Paul. So contamination losses occur when an intermediate or final product does not meet the quality requirements of internal or external customers. Maybe they don't meet the standards defined by an industry or government entities such as the Food and Drug Administration or the Environmental Protection Agency. Some examples of contamination losses include food contamination by a processed chemical such as hexane, or maybe ammonia, or quite possibly a lubricating fluid. Food contamination can also happen with biologics, such as E. coli, Salmonella, or Listeria, due to a process or problem in the process. There could also be an incorrect blend of ingredients due to a failure of automated process control. This could be for metals, paper, food, or even chemical. And the last thing where you might see contamination is in the wastewater stream that's leaving the facility. And that's where the EPA would come in. And Paul, I think you're going to take care of the consequential damage.
Yep. So consequential damage, what that is if your location would sustain a loss to either your incoming utility power, could be fuel, could be heat, steam, refrigeration, things along that line, one of your services coming in. So the questions that we're going to ask and things we're going to try to research a little bit while we're at your facility is, do you have product under refrigeration? Is it in storage? Is it in process? How much is it? What happens to it? You know, if you lose refrigeration, what happens to that product? Can you reclaim it, or is it spoiled? That has to be disposed of. The other thing you can look for is things like catalysts. So does that catalyst need to be heated, cooled? If you have a catalyst inside a reactor, if you lose the heating or the cooling, does the whole batch end up solidifying that you end up having to go into extraordinary means to remove that catalyst, get in there with jackhammers or, things like that to get it out of there? It costs you a lot much because it will cost the company a lot more money to remove the catalyst or the product. So the thing is, how much of the product is at risk? How much of it can be reclaimed? And then when you look at spoilage, who determines that product's spoiled? Is it an in-house quality assurance person, or it could be some jurisdictional authority like the USDA or state jurisdictional authority. Those are the kinds of things we look for in the information we gather. Again, we're measuring to see what kind of exposure is in place, and we try to help minimize that. Again, we come back to what's your appetite for risk. So the more our clients know what their risks and exposures are, the better they can make that decision on what their appetite for risk is. Jared?
Great. Thank you, Paul. Let's go to our next question. And I just want to remind everybody that you can use the Q&A box on your screen to ask us anything you like. We're going to answer all the questions at the end of the program. So, we want this to be interactive. We want you to engage with our speakers. So feel free to put a question in, and we'll be happy to answer it at the end. So let's go to the next question. What is boiler machinery risk engineering? And I know it's also called machinery breakdown, equipment breakdown. Can you just give us the definition there?
Okay.
Paul, you want to take it?
Sure. Many people are very familiar with property valuations where they're identifying potential loss from a fire, natural hazards, things like floods, hailstorms, hurricanes, earthquakes, just to name a few. But boiler machinery focuses on the risk and exposures of the assets at the location, like Bryce mentioned earlier. The assets, things like boilers, pressure vessels, piping systems, electrical assets, things like your transformers, motors, switchgear, and your mechanical assets, things like pumps, compressors, production machinery. So what we do is we try to gather the information and develop the scenarios as part of our evaluations. So, for instance, what's the asset? How is it installed? Does it meet industry standards? Is it best practices? Are there available applicable codes or standards that govern the installation of the equipment? What are the operating procedures and practices? Do they meet industry standards and best practices? Are you operating that machinery as it was designed, or for the best way to meet your practice? And then what's your maintenance philosophy? It could be corrective or proactive. If you're just doing corrective maintenance as things break down, you are reacting to it, and you're not a good risk as somebody who would be proactive. So what's your level of predictive and preventive maintenance? Those are the kind we're trying to develop that information. So we'll review it and evaluate your operations and your maintenance, again, going back to measuring the risk and exposures. So the other thing, I probably sound like repeating myself, but again, we collaborate with our clients to offer recommendations to control the exposures and the risks. Bryce? Jared,
Yeah, sure. I wasn't sure if Bryce was going to chime in there. That was a great answer, though. Paul, thank you. Let's go to the next question. So, we all know about, the supply chain delays that we're having today. So how do supply chain delays affect the need for boiler machinery risk engineering?
Yeah, okay, I'll take this one. So let's consider the supply chain. For any customer, there's multiple facets they have to consider. First would be the supply chain for the raw materials they're receiving to make their product. Then on the going out of the business, you have the outlet for the product. It might be further manufacturing, either at a sister facility or a totally different business who's purchasing their product, or they might go directly to the marketplace with their product. And the last thing that we're looking at with respect to the supply chain is that for the spares or replacement parts. Now, a longer supply chain delay will result in a longer business interruption loss event for those three things that I just talked about. It may also result in higher costs for parts and materials due to competition for those parts and materials that are available. And lastly, the longer business interruption lasts, it can lead to an increase of loss of market share. And the more market share that a business loses, it can be difficult or impossible to recover from that. So the impact of longer lead times can be mitigated by assessing the lead times of raw materials and increasing the buffer inventories that you have on hand. Also assessing critical equipment for increased predictive and preventive maintenance. Additionally, you can do more frequent updating of the contingency plan for current lead times of critical spares. And also, you can improve the availability of spare parts by having either on-site spares. If you're part of a larger company with many facilities that use one or two common items, you could have a network spare. And lastly, you can have agreements with other supply houses for certain equipment, such as a larger horsepower motor like 500 or 1,000 horsepower. You may not want to have or bear the cost of having that in your own facility, but you'll have an agreement with the supply house to maintain that motor on their shelf, and it is basically reserved for you. Okay, and that
Great,
will
thanks.
take care of the supply chain.
Thanks, Bryce. That was good. And again, just everybody, just so you know, you can submit a question anytime you like in the control box on your screen. And I'm going to get to my next question here for the group. So does predictive and preventative maintenance affect boiler machinery risks and exposures?
Yeah, I'll take that one. Absolutely, it does. When you're using predictive and preventive maintenance to monitor the health of your mechanical and electrical assets, you help control the risks and exposures. When you look at preventive maintenance, that's a time-based evolution where you're looking at your asset on a weekly, monthly, annual, semi-annual basis. When you look at predictive maintenance, that's where you're using technology to monitor the health of your asset. A lot of people also refer to this as condition-based maintenance. So some of the more well-known predictive maintenance technologies out there, you have things like vibration, thermography, lube oil analysis, transformer fluid analysis, or even the testing transformer, the solid insulation of the transformers. A couple other things like balancing, alignment, there's criticality analysis, business continuity planning. You can go on for a while with the well-known ones. Some other predictive maintenance technologies that normally you find at a higher rating facility, things like non-destructive examination. So are you using ultrasound, dye-penetrant, magnetic particle? Are you x-raying piping, pressure vessels to look for cracks and degradation? Things like airborne ultrasound or acoustic emissions, where it allows you to hear your machines at a higher level, where normally we can't hear them, but with this instrument, you can actually hear the ball bearings rolling around in bearings. And some people use it for air leaks, steam leaks, things along that line. Yeah, motor testing. Some of the newer technologies out there are things like motor amplification cameras. It's a new technology where you use a camera to measure and quantify the structural analysis of your assets. I've seen it used several times, and you could have a ductwork with the structure around the ductwork that holds the ductwork up there, and that structure is moving, but you don't know it because you can't see it. But with one of these cameras, it enhances what you see, and you can actually see that thing shaking, which will end up degrading the structure and could damage the duct. Some other things you can run into is torque monitoring. Again, we're using strain gauges to measure how much a shaft will twist. And then you can also use artificial intelligence, where you measure the operating parameters and you collect data from your asset, and you put it through the software, and it will tell you, based on the operating parameters and the data, what's going on with that machine. Is it normal? Is it running normal? Or do you have something going on that's just starting that could end up being a failure? So the results of using this type of equipment, if you set up a comprehensive predictive maintenance program, things that you can realize is improved equipment reliability. You can increase the life of your asset. You'll increase your uptime and utilization of your equipment. You can detect problems early and plan on corrective action. You're going to decrease your downtime. You control your costs. And then, as we always come back to, is you'll know your risk and exposures, and you'll be able to control them.
Great. Thanks, Paul. Let's go to our next question here. So, we've talked about the concepts here, and let's get into some concrete examples. Can you provide some case studies of successful B&M engineering?
Sure.
Who wants to do first?
I'll go first. Several years ago now, I was inspecting a mid-sized company that manufactured fire and security alarm boxes. So they had a lot of stamping equipment, some welding, painting, things along that line. And what happened is the main electrical switchgear had a 300 amp fuse disconnect as a main circuit interrupter. And then the rest of the distribution was molded case circuit breakers. So what I found was the location was not doing any routine maintenance as far as cleaning, inspecting, testing their switchgear. So and they weren't doing any thermography either. So what I did is made two recommendations to them. First one was to do an infrared thermography inspection. And the second one was to take a day to do a site-wide power outage to do the cleaning, inspection, testing of their switchgear. So after they did the infrared thermography, they found a couple thermal anomalies, nothing major though. But when the contractor came in to clean the switchgear, what he found was that 3,000 amp fuse disconnect had the contacts fused together. So you weren't going to open that switch no matter what you did, because they were basically welded together. Now, the fuses would have blown to protect the plant if the current going through the fuses would exceed the fuse rating. So what happened, the bottom line was the location replaced the main disconnect, and they implemented preventive maintenance tasks to clean and inspect the switchgear every 3 to 5 years. And they also made a predictive maintenance task to create a PM check to do an annual infrared thermography inspection. So the risk, if you look at this facility, they went from a poor risk rating to a typical good risk rating just by doing an infrared thermography and increasing their electrical maintenance. So if you look at if we would be looking at this today, that loss situation, the property damage would probably approach $500,000 just for the switchgear, and it would probably take 3 to 4 months to get that gear and get it installed if you had a loss. And a loss in this situation would have been extensive arcing in the main disconnect, and you're burning up your switchgear, and you'd have significant business interruption. Bryce, you got some examples?
Yeah, I sure do, Paul. So the one thing I'd like to say is that when we're on site performing these assessments, we have an opportunity to provide recommendations that hopefully they'll take care of an issue that we find while we're on site, but it will also create some sort of behavioral change that will have a long-term benefit for that company. So during an assessment visit to a roof panel manufacturer, I observed that they were performing annual oil changes on 2 gearboxes that are on their main production line. Unfortunately, they were not assessing the condition of the oil, and they thought they were doing a great job, which in thinking from years past, yes, time-based PMs, they were doing a great job. But they were also missing an opportunity here. And the opportunity was to perform an analysis of the oil before they drained it out of the gearboxes. When they did the analysis, what they found in one of the gearboxes is that they had an unusual amount of wear particles inside. And as it turned out, these wear particles were coming from one of the bearings. The upside to this is that they were able to plan for the replacement of this gearbox prior to it failing while in operation. So they did replace it during a scheduled plant outage. The lead time on that gearbox was about 8 months. And the total loss event, if it would have failed during operation, it wouldn't have shut them down altogether, but they would have been able to continue at a much reduced rate. The loss event would have been about $20 million. So they were able to avoid that loss. And on the upside, they were able to take that original gearbox, rebuild it, and now they have that on the shelf as an on-site spare in case one of the other 2 gearboxes fail. And the other thing that has now changed is that they're analyzing the oil in all their gearboxes on an annual basis. Jared?
Yeah, that's great. Both of those examples were really strong, and it just really helps us to understand, right, these concepts, but in a grounded in an example. So thank you both for sharing those. We just have one more question for our panelists, and then we're going to get into Q&A. We already have some questions rolling in, so please ask yours, and we will be able to ask them the panelists at the end. So we're going to do one more question for me, and then we're going to go right into the Q&A. So without further ado, let's get to it. So how do risk assessments by independent consultants differ from those bundled with underwriting?
Jared, I'll take this one. So in most cases, our customer is the business we are assessing. However, there are times where the customer might be a broker or an insurance carrier who does not have the in-house risk engineering staff or expertise to perform these assessments. Now, the assessments performed by independent consultants usually start at $1, not at the deductible set by the insurance company. This allows us to identify risks and risk reduction strategies for losses that don't reach the deductible. It can also lower the cost to implement the risk reduction strategies. Therefore, the recommendations or improvements that we develop can have a major financial impact on the business by improving the stability and reliability of operations with a relatively low cost of implementation. The independent assessments usually are performed by risk consultants who have an experience base across dozens of occupancies. This could include paper mills, printing, food or grain processing facilities, specialty steels, power generation, and maybe even aerospace. When an assessor for an insurance company is doing an assessment, typically the experience of that assessor is driven by the occupancies written by that company's book of business. This could be light manufacturing, maybe office buildings, or healthcare. So the insurance companies might be somewhat limited in their experience base, whereas the independent consultants generally have more experience and have a much broader experience base. Jared?
Great. Thank you so much, Bryce. And Let's just do a quick recap of today's webinar, and then we'll get into the Q&A questions. So what we learned today is, risk engineering is key to protecting against machinery breakdown. Supply chain issues make risk engineering even more critical. Independent risk engineering is superior to the engineering bundled to underwriting for a number of reasons that Bryce just discussed. And then we learned about some specific examples of boiler machinery risk engineering successes, and those were really good to hear. So without further ado, we're going to get to the Q&A portion of the webinar here. Please ask questions. If you see basically our pictures on the screen, our video on the screen, underneath that, you can click the question box with a little question mark, and then add a question in there, and we'll see it and we'll answer it. We already have some good ones coming in, so ask away, and this is the time. While we do the Q&A, I'm just going to leave this slide here with our email addresses and ways to contact us, just in case you'd like to get in touch. So, okay, let's go to our first question. What is the difference between jurisdictional inspections and boiler and machinery risk engineering? Who wants to take that?
Yeah, I'll jump in on this one, Jared. So let's talk about who performs these inspections. The jurisdictional inspections are totally different than the boiler and machinery risk engineering. And the skill set of the personnel doing the inspections is very different. The jurisdictional inspections are basically a safety inspection, and the criteria for those inspections are defined by the jurisdiction where the objects are located. That jurisdiction could be a city such as White Plains, New York, or New York City, or maybe Chicago. Might be a state or a province in Canada. The B&M risk engineering requires a much broader base of knowledge, which I briefly discussed earlier. And typically that knowledge is gained over many years of visiting the different occupancies and constant education, especially in emerging technologies for preventive and predictive maintenance. And in today's world, with new materials, new processes, it becomes incumbent upon the B&M risk engineer to stay updated on all these different changes.
Great. What is the best way to create a contingency plan to deal with losses?
I'll take that one, Bryce. Basically, with a contingency plan, you're looking at an asset. So basically, you could be a boiler. So if you look at the assets that are critical to your production and your processes, it could be a boiler, transformer, even switchgear, compressor, maybe. So take, for instance, a boiler. So do you know where to get a rental? How to get that rental to your facility? Once you get it to your facility, do you know where you're going to park it? Do you have the piping connections, electricity to run that boiler, fuel, things along that line? When you develop a contingency plan, what you want to do is look at your suppliers for the assets. And do you have one or two, three? Would be great, better than one, because if you have one supplier for a rental boiler or a transformer, when you sustain a loss and you have to go get and you have need of that rental, you go to the vendor and they have it out rented, or it's somewhere else, might be in for repairs or something like that. So by having several outlets, several vendors that you can get a rental boiler from, that's ideal. And then how big of a boiler do you need? How much pressure do you need to run your facility? That's the kind of thing you want to have in your contingency plan. You want to have it a written plan. If you have it on a computer, it's great. And the other thing you want to do is not have your contingency plan at the office or at your facility? Because if you have a fire or some kind of event there, can you get to that plan? So it's always good to have several copies, different locations.
That makes sense, and maybe even an electronic copy that everybody can access. That's really good. Yeah, we got plenty more questions here from the audience, but please submit yours. We'd love to hear from you, and we'll just keep rolling with some Q&A here. Next one is where do asset management and reliability programs come into play that address electrical, mechanical, and control and instrumentation issues?
I guess I'll take that one. Asset management reliability programs. When you get into those programs, they start getting down into the weeds on your assets, and you can be looking at: did you have a failure? What kind of failure was it? And you start getting down to root cause analysis. Things we do here at GRC, we do some asset management and reliability troubleshooting, where we'll look at your program and be able to tell you where you need to do improvement on that. We don't get into the actual implementation of the asset management and reliability, but we can help direct you on where your shortcomings are and where the gaps are, and how to make those gaps, how to fill those gaps.
Great. Here's another one. How are BI values calculated or anticipated from a boiler machinery perspective? Is this similar to property loss expectancies?
Yeah, I'll take this one, Paul.
Okay, go ahead.
Yeah, that's a very good question. And really, the business interruption values, they're developed using a very similar process. We do start with the same values as far as what the annual business interruption value is for the location. And when we start looking at the loss events, we need to come up with the loss events that, for let's take for instance, a transformer. And we've seen the lead times for some transformers just exponentially grow in the last year, where previously it would take you 12 months to get a transformer of a certain size and voltage. Now it's taking double that time, 24 months, to get that same transformer. So what that does to your business interruption loss, the PD portion of the loss event is pretty much the same, but the BI portion of it is now much larger, based because solely on you have an additional year to get that piece into your facility set up and operational. So, as Paul discussed during the contingency plan portion of this, if you have an effective contingency plan, that can greatly reduce the amount of time that your business is shut down.
Absolutely. Yeah, and looks like we've got two more here from the audience, but please submit them if there are any more. We'll get to them for sure. This person, I think you had mentioned, contamination losses and consequential losses in the beginning, and they want to know, are potential contamination losses and consequential losses part of BI loss calculations?
I'll take that one. Normally, no. I'd have to, it's been a while since I looked at an insurance policy, and have to go back to somebody with some more underwriting type of experience. But normally your business interruption is separate from your consequential and your contamination coverages. Your what they call direct coverage would be the amount of money that they would be paying out directly to the loss of the asset. So if it's the boiler and it costs you $150,000 to replace the boiler, that's direct coverage. Your business interruption, your contamination, consequential, that's referred to as indirect coverages. So I hope that answered your question.
And the final question here is, for product losses, are these typically covered under commercial property policies?
I don't.
Again, you know,
So,
we generally do not get a look at the policies. So we would have to get in touch with the broker or whomever our customer is and find out exactly, you know, I'm going to say what their coverages are if they want us to include that type of loss event. Paul, anything to
absolutely.
add to that?
Yeah, I mean, when we go out, we're going to look to see what's the risk, what's the exposures, what's out there, and report back to you, the client, or the broker, if the broker hires us, as here's what the risks and exposures are. And then they can, usually the client will talk to their broker and the insurance company to say, we have these risks, these exposures, do we need this type of coverage? And then you work your coverage out with the insurance company. But that's where it goes back to knowing your risk, knowing your exposures.
Great. I just want to thank you both for doing this. It was really enlightening for me personally, and I'm sure for the audience as well. Thank you again for sharing your knowledge. And I just want to let everyone know that you can contact us. All three of our email addresses are here on the screen. So give us a call. Give us an email if you'd like to discuss this any further. And we just want to say thank you for sharing a part of your afternoon or your morning with us, wherever you are in the world. So thanks again, and we're going to sign off.
Thank you, everybody.
Thank you.